All right, so we're going to start walking through the preparing and diluting solutions lab. Today, the idea is hopefully we're going to go through a combination of I'm going to we're going to do some of the pre-lab calculations, and I'm also going to kind of walk you through generically some of the procedures that you're going to do with this. So let me actually. Let me get one of the same ones that have the same stuff that you guys have on it. Okay. So solutions are an important part of chemistry. Oh, sorry, guys. Okay. But how are accurate concentrations of solutions prepared? In this lab activity, a copper 2 sulfate solution will first be prepared, then diluted to prepare several other solutions with different concentrations. So our goal here really is to demonstrate the proper lab technique to create a 0.1 molar copper 2 sulfate stock solution and show proper lab technique for creating both serial dilutions and dilutions of a given molarity. Okay, now, and you might not know the difference between those two, might not make sense right now, but you'll understand when we get through it. So this is all stuff from unit, like the chapter 4 stuff that we've already done. So you guys have already done all of these. These are all equations and calculations and stuff that you already know how to do. Okay. So this talks about the molarity equation. Molarity is moles over volume in liters, right? We already know all that. They're showing you how to figure out the number of moles necessary to prepare a solution. Like, how do you find the number of moles? So essentially, you take all you're doing is you're taking the volume times the molarity that you want to get, right? The volume in liters times the molarity that you want to get, and then that's going to give you the moles that you need. And then depending on the substance, you're going to you have to figure out the grams, because we don't really measure things out in real life in moles. So to figure out the grams that you need, you're going to take the moles, convert it from moles to grams using the molar weight, like adding it all up from the whole, like from the formula, right? Or luckily, the things that we use actually give it to us for most of the chemicals. Okay. So they go through all the math. They're just doing an example here, finding out how many grams of sodium chloride to prepare 500 milliliters of a 0.8 molar solution. Okay. All right. Next page. Okay. Once you've done the calculations to determine how much of the solute you need to correctly prepare the solution, precise analytical techniques must be followed when actually making the solution. The steps below outline the proper solution preparation procedures. So, hold on a second. Let's see. All right. So now that I know I can flip back and forth, obtain a piece of volumetric glassware. So that's the volumetric thing, is the thing that I put out with all you. Like, I don't have enough for everybody, so some people kind of have one between you, but I just put it there. You're not actually gonna do this right now. You'll do this later, but so you can actually see what a volumetric flask looks like. So if you look at it, some of you have 50s like this, some of you have the hundreds. But if you look at it, it's essentially, it tells you down here what the volume is, right? And then if you look, there's the only mark on the whole thing. Put my hand on, there's one line on the neck. Everybody see that? That line on the neck? That line represents the volume that is on the flask. So you get that filled to that line, and in mine you have 50 milliliters. If the solution is to that line, those of you that have 100, obviously, if it gets to that point, it would be 100. Okay. So volumetric flasks literally, like, they're designed basically to do one thing, which is to make solutions. All right. So how do you go about making your solution? Precisely weigh out the number of required grams that you determine, through all the math. You figure out how many grams of the solute, the solid chemical you need. Okay, you weigh that out. Then into a weighing dish. And then what you're going to do, now let me, hold on one second. Okay, I'm going to switch my view here I'm going to be reading off of these steps here, kind of going through them, but I'm going to, up here on the overhead, I'm going to visually show you as we go through it, what it's going to kind of look like. Okay, so let's see if I can. All right, so you weigh out the number of grams of the solution that you need. So let's say I've already done that. I've weighed out my number of grams into a weighing tray. Okay, then it says you're going to transfer this into the well, wait a minute. Okay, so this one has you do it into a beaker. Sometimes you do it right into the volumetric flask. This one is going to have you do it into a beaker first. So measure it out, transfer it into the beaker, making sure the beaker obviously is large enough to hold whatever. That's weird. Okay, so you transfer the solid into the beaker. Now, this has to be to get the right concentration, especially when you're dealing with small amounts, you have to be really exact. So you got to make sure that all of the solid gets transferred. So the way we do this usually is you take this and you can make sure it all gets transferred, and then use a wash bottle, and you just rinse any residue that might be on this into the beaker. Okay. Now, it doesn't matter how much water. You don't want to get a ton, because I think what we're doing is 100 milliliters. So obviously you don't want a ton of water in here, because then you can't go over that amount. You don't want it right on, because that's going to screw you up. So you just want enough basically to clean out the tray. All right. So now we know we've got all the solid that we measured in here. There's a little bit of water in here as well, right? Okay. This is called. It says this technique is called quantitatively transferring. It's where you're making sure you transfer literally all of it, the quantity. It says the rinse water may be enough water to dissolve all the solid in the beaker. If it is not, add a minimum amount of distilled water or deionized water to dissolve any remaining. So you want it all dissolved. Now, since mine wasn't really measured out here, I don't know how much it's going to be. But basically, you're going to add water until you get it all dissolved. Okay. All right. So you're going to add water. You're going to add water and kind of get it all dissolved. You can use a stirring rod to help dissolve it. Just if you use a stirring rod, you've got to make sure that when you take the stirring rod out, you rinse rinse the stirring rod into there to make sure that there any kind of part of the solution that's on there doesn't get stuck on the stirring rod. Okay. So once you get it like that, then what you're going to do is you're going to transfer the solution to your volumetric flask using a filter. Now, you guys are going to be using the hundreds, which work a lot better with these, with the funnels, I mean. I thought I had a smaller funnel for them, but this will be fine. So what you're gonna do is you transfer it to the flask, and then basically you're gonna do the same thing that you did the um, with the weighing tray with the beaker, which is use the DI water and make sure that there is no traces or residue of any of the solution. You make sure it's rinsed and everything gets transferred to the flask. Make sense? Same thing with the funnel. Okay, now mine's not going down because my funnel's actually too big for this, but it's like sealed now. There we go. Okay, same thing with the funnel. You rinse, making sure all the solution gets down into the flask. Okay. All right. Then and then again, now mine's already almost there because I'm using a real small one. You got to be using the hundreds, but it says fill the volumetric flask with distilled or DI water. When the flask is about 1/2 to 2/3 full, cap the flask and invert it several times. Well, mine's already there, so I'm going to cap this, invert it. So for Harry Potter fans, you're making a potion. All right, you invert it, mix it up. Then continue filling the flask until the liquid level is almost at the mark. This is the most crucial part. You're going to continue filling the flask, okay, until the liquid. Now, you can add liquid a little faster. Mine's filling up pretty fast because it's a 50. Yours are hundreds. So if you, like what I always tell people, I was like, if you want to use the funnel still, you can unscrew the top off the distilled water bottle and you can add water, but be very careful. Here's the thing, even with the hundreds, it's gonna, when it fills here, when it hits this neck, that's a small volume diameter. It's gonna fill fast. And the one thing you do not, under any circumstances, want to do is you don't want to blow by that line. You blow by that line, you fill it past that line, you're screwed. You got to start all over again. There's nothing you can do. You can't get it back because you've added too much liquid and it's the concentration is off, and there's no way you can remove liquid without removing some of the solution now. So the main thing is, like, you cannot blow by that line. So basically what you do is you keep filling and you fill and fill and fill until you get close to that line. Then when you get close to the line, you can still use this, or I will also have I'll also give you guys pipettes. You can either use this or pipettes. These are pretty good. You can still usually add this drop by drop, but when you get really close to that line, and you can see even on this one, it's filling fast. Okay, so when you get close to that line, usually what I do is this: I cap it, invert it to shake it a little, just to try to get any like beads of solution or anything that are on the sides down. Okay, then very carefully fill it. Don't forget, you're gonna, especially with these, because these are small, the necks are small, you're gonna have a meniscus, the curve, right? So remember, you want the bottom of that curve on that line. So you're gonna have to kind of look, and you're gonna add this, and very carefully get it to that, right to that line. Okay, don't blow by. I blew by the line, but it doesn't really matter because I'm just showing you what to do. Don't blow by the line. Be very careful. You can always add more till you get to the line. You can never take away. So once you get it to that line, you mix it up real well. Okay, and then you're going to transfer it. I'm going to have another, like a chemical container for you to transfer it into and label. But once you hit that line, you know you have 100 milliliters, or this is a 50, but like yours will be 100. You'll have 100 milliliters of whatever the molarity is you're looking for, because you know that with that combination of water and solid, that's the molarity that you were trying to get to. Does that make sense? Okay. Then when you go to transfer it to the container or whatever, just make sure it's really mixed well. You go to transfer it to the container, you transfer it. It's not going to be a beaker, but you transfer it to the container. Okay. Transfer it to your container. You got to cap. You know that container is that molarity. Okay. You're not going to be rinsing this out or anything, because if you add any more water, you're changing the concentration. You're just transferring it. You know that this, even if you don't get it all out, remember it's all mixed up, right? So whatever the concentration is here is the same as whatever's left in here. It's fine. It's the same concentration because you've got it all mixed. Does that make sense? Okay. Any questions about that? Okay. All right. So let me. So let me switch this. Making the solution is the first step of what you're going to do. Did I not switch that? There we go. Okay. So this part down here is diluting the solutions after you've got your stock made. That's going to be the next steps. Okay, but in order to make the solution, we're going to do the pre-lab exercise here. So you guys are actually going to need to get out another sheet of paper, like a separate sheet of paper, because they don't give us room to do it on here. If anybody wants paper, there's some here you can grab. Okay. So go to the pre-lab exercise. It's page 3. All right. So the molar weight will be the same. All right. Calculate the number of grams of copper 2 sulfate pentahydrate, CuSO4.5H2O. I don't know if you guys remember way back Chem 1 stuff. We did some like the naming of the hydrates and stuff, but that actually does impact the. Sorry, this is not focusing. That does actually impact the whole formula weight. So, the nice thing is they give it to us right on the bottle. So, right there, formula weight 249.69. So, copper 2 sulfate, the CuSO4. So, this is number 1, is 249.69 grams per mole. Okay, I'm just writing that down because we're going to need to use that to get the information. Now, what we are trying to do here is we're trying to figure out the number of grams of the copper 2 sulfate that we need to prepare 100 milliliters of, so we want a volume of 100 milliliters of molarity 0.10 molar solution. That's what we want to make. Okay, remember to include the 5H2O when determining the molecular weight. Well, we've already got that just off of here, so we're not going to worry about that. Okay, so let's find the amount of grams that we're going to need. So first thing we're going to want to do is we're going to turn our volume from milliliters to liters, right? So I'm just going to do it moving the decimal. So 100 milliliters is 0.1 liter. Okay. And actually, if you're worried about significant figures, significant digits, this technically would be 3 because you want it exactly 100. So if you're so just so I don't confuse people, you would want, I guess, technically like that if you're thinking of it in terms of significant figures. Okay, so we need to find the grams, right? So you can do it either way. You can do the kind of equation and then convert. I do it the dimensional analysis. So I'm going to start with the liters, and I'm going to use the molarity. Remember, molarity is moles over liters, correct? So it's going to be 0.10 moles over 1 liter. And I want to know the number of grams. So I'm going to use my formula weight to convert from moles to grams. So I know it's 1 mole. This is of the CuSO4 stuff, right? For 249.69 grams. Okay. Everybody with me so far? Know where I'm getting the numbers from? All right, so all we need to do now on this is the math. Literally just had my calculator. There it is. So 10.1 times 249.69 should be 2.4969. Okay. So now again, significant, everybody's like always like significant figures. Well, technically this only has 2, but again, this is getting kind of in a sort of in between type of thing where we're trying to get something that is accurate to at least 2. So if we take it further, that's okay. I'll tell you that the scale I'm going to have you guys use is that, I don't know if you guys remember, I have that digital scale, the one that will measure as accurately as the other ones, but it's a digital one. I'm going to have you guys use that. So let's share. You'll have to rotate it, obviously. I'll just have it up here, but I'll have you guys use that to get out the grams. That one goes to 3 significant figures. So basically, we're going to take this to, so 2 point, or I mean, not 3 significant figures, it goes to 3 decimal places. So it'll be 2.497 grams of the CuSO4.5H2O, whatever. Okay. So that's the number of grams. Okay. So when you guys go to start this tomorrow, you're gonna take I'll have the copper sulfate over there. You're gonna measure out the grams, get the grams into your weighing tray, and then take it from there and do what we just talked about um, with your volumetric flasks and making the solution. Okay. All right. Questions on that?